There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros after it.
Say what?
This is the largest mismatch between theory and experiment in the history of science.
Wow.
Scientists have looked long and hard into the origins of Earth's water, and what they've found is amazing. Our planet shouldn't be wet at all. Shouldn't be wet at all. Our planet shouldn't be wet at all.
Why? 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 Why?
The place where the Earth is right now seems very dry. So if the Earth formed as a dry rock around a hot young star, then how did this water get here?
Every possibility has problems. Every possibility has problems. No! And we want to know the answer.
Tracing the exact source of Earth's water is surprisingly complex. The journey starts over 4.6 billion years ago, during the formation of our solar system.
But you plug the formula into a laptop computer today, and you can prove to yourself, think with me, if the moon is moving away at 2 inches per year now, well, if I go back 1 year, it would be 2 inches closer, correct? Another year would be 2 inches closer. But as the moon starts to come back towards the Earth, well, then the force of gravity starts to increase, is that correct? And the rate at which the moon comes back gets faster and faster, correct? Now again, as I said, you can prove this in a laptop computer. If you go back in time, the moon would come back in, spiral in, and hit the Earth 1.4 billion years ago. Now, evolutionists say that the Earth and the moon are the same age. They say they're 4.5 to 5 billion supposed years old. Most of them say 4.6 billion. But if evolutionists were telling the truth, then that would mean that the moon was attached to the Earth for the first 3.6 billion years. Is that correct? And then it has been moving away ever since. Have I got that right? Hello? Now, there's something else I want you to notice here. Did you notice the bouncing arrow? And did you notice down here, I'm going from the age of the Earth at 4.6 billion, and it's getting younger. So did everybody see that now? I want you to, okay, right, here's the bouncing arrow. And then the age of the Earth gets younger. So, was that cool? Well, let's think about this too. If the moon comes back towards the Earth and the force of gravity gets in, ever larger, well, what's it going to do? Well, what is the major physical impact of the moon upon the Earth? It is tides, correct? Now, if the moon starts to come back towards the Earth, well, let's think about this. If the moon comes back towards the Earth, the tides would get higher and higher, correct? Right? Now, if you go back 1/2 billion years, and again, just in a laptop computer, well, the tides on Earth would rise 1 mile high twice a day. I think my first question would be, do you know how to breathe underwater? And keep in mind, if the tides rise 1 mile twice a day, just in your mind start thinking about erosion for just a minute, okay? As a matter of fact, think with me for a moment. Since the Roman times, 2,000 years ago, the English North Sea coast has eroded 2 miles west along the east coast of England. We know of 35 villages in the Roman census 2,000 years ago that have been completely lost into the sea. That's an average of 5 foot per year. Clearly that erosion rate, cannot have been going on for millions and millions of years. Is that right? There simply wouldn't be in England.
Every possibility has problems.
A vast cloud of gas and dust hangs in space. A vast cloud of gas and dust hangs in space. Hangs in space.
Now let's turn it on and let's see what happens. Oh my God, look at it. Woo! This is awesome. They all pop.
Hangs in space.
They all pop.
Inside this cloud, atoms of hydrogen and oxygen proliferate.
Oxygen is one of the most abundant atoms in the universe. Hydrogen is the most abundant atom in the universe. You're going to get a lot of whatever it is they form.
Over millions of years, these highly reactive atoms bind together to form H2O, water.
Water is a fairly simple molecule. It's made of 2 hydrogens and 1 oxygen.
Why?
Well, so if you mix these two together, hydrogen and oxygen, each one separately is kind of happy the way it is. But if you want to combine them into a water molecule, you've kind of got to get those electrons back up out of their wells, back up, give them some of that energy they lost, get them excited. And the time-honored way to do that is to strike a match. Strike a match.
The paper failed to burn because it didn't have any oxygen, so how about something that has its own oxidizer, such as gunpowder? You see, this is a mixture of charcoal, sulfur, and potassium nitrate. When heated, the potassium nitrate gives off oxygen, which the sulfur and charcoal uses to burn. So I've got a little bit sitting in there. Let's apply the laser goggles, and let's light it off. First in the atmosphere, and then in the vacuum. Okay, as you can see, it produced lots of smoke and burned rather quickly. Most of the air is now gone. Let's see what happens. The gunpowder did not ignite. Let's try again more in the center of the pile. And that's it. The gunpowder does not burn. I mean, it burns when the laser's on it, but other than that, no. It doesn't change from one particle to the next. That's interesting. So what I think is happening here is that the hot gas is produced from the burning gunpowder. Normally, as it expands, it encounters other gunpowder particles, heating them up and causing the chain reaction to occur. But in the vacuum, the gases expand so rapidly that they're not able to heat up the nearby gunpowder particles, and so the flame or the fire does not happen.
Why?
This newly formed water sticks to dust grains inside the gas cloud, slowly building up into crystals of ice.
And the time-honored way to do that is to strike a match. Strike a match.
No, it doesn't change from one particle to the next. That's interesting.
Eventually, the icy, dusty cloud becomes so dense, it starts to collapse under gravity.
Oh my god, look at it. Woo! This is awesome. They all pop.
This begins the process that forms our solar system. There's enough water here to fill the Earth's oceans 3 million times over.
When we see stars that are forming right now, and we study hundreds, thousands of them, we see disks of material beginning to orbit around the young stars, gas, dust, and there's certainly quite a bit of water in that material.
Gravity pulls more and more material into the center of the cloud, raising pressure and temperature. Eventually, the extreme forces spark fusion, and a protostar, our infant sun, bursts into life.
Strike a match.
Look at it. Woo! This is awesome.
Bursts into life. Bad news for the water surrounding the newly born star.
Why?
Every possibility has problems. The environment of a star when it forms is incredibly hot and violent. Any water that was existing in that region, because water is a volatile material, would be destroyed. Water cannot exist near a star early on during its formation. Water cannot exist near a star early on during its formation.
must have flown in from far away, on meteoroids or comets or other bodies originating in the outer solar system where they were far enough from the sun for frozen water to survive.
I think I can smell shite.
The dirty ice balls we call comets are a logical candidate for the source of our water, but were ruled out when we discovered that they were far richer in heavy hydrogen than Earth water. Heavy hydrogen has a neutron as well as a proton in its nucleus, and for every million hydrogen atoms in Earth water, about 150 are heavy ones, while typical comet water has twice that many. These mismatched chemical signatures suggest that Earth's water couldn't have arrived on comets. It turns out that the most likely source for Earth's water is a type of meteorite called a carbonaceous chondrite. Chondrite is just the name given to the class of stony meteoroids that most commonly strike the Earth. But only the carbonaceous chondrites contain water, as well as lots of carbon if you couldn't tell from their name. They have water in them because they formed out beyond the sun's frost line, and what's more, their water has levels of heavy hydrogen similar to that of Earth water, strongly suggesting that these Earth crashers are the source of our ice caps, clouds, rivers, and oceans. And thus the water that turned our planet into a blue marble came quite literally out of the blue.
Yes, I can definitely smell shite.
And today, scientists continuing to study Comet McNaught have reported another discovery that stunningly confirms the electric comet theory. That is that the material in the comet's dust tail is, quote, electrically charged. The team was attempting to learn about the extraordinary dust tail, specifically the structured bands of dust, or striations, which did not disperse in the, quote, vacuum of space, but stretched for over 100 million miles behind the comet. Previously, the Great Comet of 1744 was said to have presented the same mystery in its time, when it produced 6 tails which were observed from Earth. Today, almost 3 centuries later, scientists utilizing a new image processing technique are able to study the formation of the striations in McNaught's dust tail. What they have found was completely unexpected. It has always been the electric universe position that most comet activity is the result of the comet moving through regions of changing electric potential. The reason comet activity tends to increase as it moves closer to the sun is not due to sublimation of invisible, hypothetical water ice. Is not due to sublimation of invisible, hypothetical water ice. Indeed, every comet nucleus image to date has appeared rocky and desiccated. An obvious problem is the comparison of comet jets to the blast of a garden hose is completely inappropriate.
And this is the fire hose rodeo.
Is completely inappropriate. In the so-called vacuum of space, what mechanism collimates the jets, causing them to not disperse as comet scientists had predicted?
Look at it. Woo! This is awesome.
And they said, do not worry. Do not worry. We'll give you one of the white coats we all wear over there in the chemistry department. I said, what good's a white coat if the thing blows up?
Every possibility has problems.
We have hydrogen and oxygen combining to form water in a very hot flame, sometimes used to cut steel. The little color from sodium in the...
Bad news for the water surrounding the newly born star.
No, it doesn't change from one particle to the next. That's interesting.
Strike a match.
No.
Strike a match.
No.
Woo! This is awesome.
Water cannot exist near a star early on during its formation.
And thus the water that turned our planet into a blue marble came quite literally out of the blue.
Yes, I can definitely smell shite.
What?
We're off by a factor of 10 to the 120. That is 1 with 120 zeros after it.